Welcome back to my channel. Today in this class we are going to discuss about is matter around us pure. Let's start the lesson. These are all some of the topics we are going to discuss in this lesson. As we can see in day-to-day life, whatever the material we are seeing like juice, sugar, milk, coffee, tea, fruits, everything whatever we are observing, whether it is a pure or mixture. So as we look around, we can see the most of the material are exist. Most of the materials are mixture. For example, seawater, minerals, soil, etc. Suppose if I am seeing one material is a pure substance, that means consisting of a single type of particles, or a substance is a pure single form of matter. A pure substances we can also define as a substances is a pure single form of matter or the same chemical nature. We will discuss about mixture. What is mixture? Mixture are constituted by more than one kind of pure forms of matter. Suppose if I am saying sugar is a pure forms, that means sugar is a same throughout. Sugar, when it is mixing with the water, then it is called as a mixture. We can see that mixture contains more than one pure substances. We can say that in a mixture there are two types, that means homogeneous mixture and heterogeneous mixture. Mixture which has a uniform compositions throughout, such mixture are called as a homogeneous mixture. The example is salt dissolved in water or sugar in water. When sugar completely dissolves in water, it forms the homogeneous mixture. The second type is heterogeneous mixture. Mixture which contain physically distinct parts and have a non-uniform composition. Such mixture are called as a heterogeneous mixture. For example, oils in water. Suppose if I mix oil and water, it is not possible. That's why it is called as a heterogeneous mixture. We can identify the what are the content present in there. Then it is called as a heterogeneous mixture. These are the two types. As I already told you, what are the example of homogeneous mixture like sugar in water, salt in water, the solute which is completely dissolves, then it is called as a homogeneous mixture. For example, heterogeneous mixture example is bubble tea. Bubble tea having the mixture of milk, water bubbles, sugars. It is so we can identify what are the components present in it. Then it is called as a heterogeneous mixture. Solute dissolved in solvent to forms the solution. In sugar solutions, sugar act as a solute, water act as a solvent, so it dissolves to forms the homogeneous mixture. Then it is called as a solution. Next, we will learn about solution. A solution is a homogeneous mixture of two or more substances. I already given example of sugar solution. Alloy. Alloy is a two or more metals or a metal and non-metal mixture. And gas, which contain nitrogen, oxygen, halogens, noble gas. A solution has a solvent and a solute as its component. A component of a solution that dissolves the other component in it, then it is called as a solvent. That means it is usually present in large quantity. The component of a solution that is dissolved in the solvent, it is called as a solute. That means it is usually present in a less quantity. For example, aerated drinks like soda water, etc. or gas in liquid solution. These contain carbon dioxide as a solute and water as a solvent. Next, we will discuss about what are the properties of solution. A solution is a homogeneous mixture. The particle of a solution is smaller than 1 nanometer in diameter so that they cannot see by the naked eyes. The seen. Because of they are small in particles size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in this solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed. That is why solution is stable. As here shown in the picture, a solid has a fixed volume and the shape, but liquid has obtain the shape as the container, but gas as it can expand and the volume also increased. Next we will learn about what is the concentration of solution. Concentration of the solution is depending on the concentration of the solute present in solvent. Suppose if you consider a saturated solution means the concentration of the solute is very less. Depending upon the amount of solute present in a solution, it is called dilute concentration or saturated solution. That means enough quantity of solute dissolved in the solution or solvent. Then it is called as a saturated solution. The amount of solute present in the saturated solution at that temperature, it is called as a solubility. If the amount of solute of containing solution is less than the saturated level, then it is called as a unsaturated solution. As you can see in this picture, one is concentrated solution, another one is dilute solution. In dilute solution, the number of particle of solute is very less compared to the concentrated solution. But in dilute solution, maximum number of solute is dissolved. But in concentrated, we cannot say that solute is completely dissolved. The concentration of the solution is the amount of solute present in the given amount of the solution. Here I give an example. If a solution containing 40 gram of common salt in 320 gram of water, calculate the concentration in terms of mass. So we can write as mass of the solute is 40 gram, mass of solvent is 320 gram. So the mass of the solution is mass of the solute and mass of the solvent is give the 360 gram. But mass percentage of solution is equal to mass of the solute by mass of the solution into 100. It gives 11.1 percentage. Next we will learn about what is suspension. In a non-homogeneous system has a solid or dispersed in liquid or called as a suspension. A suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended throughout the bulk of the medium. It is a kind of heterogeneous mixture where the particles we can see, like that same thing here, the particles we can see through light or a flashlight. We will discuss about properties of suspension. As I already mentioned, it is a heterogeneous mixture. The particles of suspension we can see by naked eye. The particles of suspension can scatter the beam of light. It makes the path visible. The solute particle can be settled down when the suspension is undisturbed. Same thing, it is unstable. They can separate it from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. These are all the difference between solution, colloid and suspension. And particle size also differs. Next we will learn about colloidal. Colloidals having a very fine particle substances that are dispersed in the medium. The particle of a colloid are uniformly spread throughout the solution. The relatively smaller size of a particle as compared to that of suspension. The colloidal solution is a heterogeneous mixture. For example, milk. The small size of the colloidal particle we cannot see with the naked eyes. This scatter beam of light. This is called as a Tyndall effect. As you can see in these examples, these colloidal particles are very small. We cannot see by the naked eyes, and we cannot even they were not even settled down like a suspension. Tyndall effect can be observed when the sunlight passes through the canopy of the dense forest. As you can see in this picture, Tyndall effect in this picture we can see when the sun rays passes through the dust area. Now we will see about properties of colloids. Colloid is a heterogeneous mixture. The size of the particles of the colloid is too small to be individual seen by the naked eyes. The colloids are big enough to scatter a beam of light passing through it and make its path visible. They do not settle down when left undisturbed. That is, colloid is quite stable. They cannot be separated from the mixture by process of filtration, but a special technique of separation known as centrifugation can be used to separate the colloidal properties. These are the properties of colloids. The components of the colloidal solutions are dispersed phase and dispersed medium. The solute-like components or the dispersed particles in a colloidal from the dispersed phase. The components in which the dispersed phase is suspension is known as a dispersing medium. Colloids are classified according to the state of solid, liquid, gas of the dispersed medium. Here I give an example. If dispersed phase is liquid and dispersing medium is gas, for example aerosol type, this type is called as aerosol. For example, fog, clouds, mist. These are all some of the example I given below. Next we will study about separation, the component of the mixture. In heterogeneous mixture, I already told you we can identify the pure substances. So we can separate the pure substances in heterogeneous mixture. As you can see, in day-to-day life there are physical methods like hand picking, sieving, filtration we can use so that we can separate the pure substances from the heterogeneous mixture. We can identify easily, like you can see in this picture, sieving by the small particles can be separated, by filtration also, and some magnetic properties can, if the mixture is attracted to the magnet, that also easily separated from the mixture. Next we will see how can we obtain colored components, for example dye from solvent. We will see, we know that actually ink is a mixture of dye in water. Let's separate the ink that is non-volatile. Water is a solvent and it is a highly volatile. So to do this experiment, as I already shown in this picture, take a beaker which is covered with watch glass, and beaker, half of the beaker is filled with water, and we can pour the ink mixture on the top of the watch glass. Let's start heating. As I already shown in this picture, first water will be heated, like it start boiling. Because of that temperature, watch glass become hot and water in a dye start evaporating. As we continuously heating, the solvent which is present in dye will evaporate, but dye will stick to the watch glass. Like this we can separate the component present in dye, like water and coloring agent. Using this method we can separate the volatile component from non-volatile component through evaporation. Next we will study about how can we separate cream from milk. The solid particles in liquid are very small and they can pass through filter paper. For such particles, the filtration is a technique we can use it to separate. So that mixture can be separated based on the centrifugation. The centrifugation states that the denser particles are forced to the bottom and the lighter particles stay at the top when spins rapidly. As you can see in this picture, the mixture is placed in a test tube and we can on the centrifugation so that the machine will be rapidly spin so that the solid will be separate from the liquid. Experiment we can do, like when take the cream full of milk in a test tube, centrifuge by using a centrifugation machine for 2 minutes. The denser particles are forced to the bottom and the lighter particles stay at the top. This is the principle and the experiment we can do in laboratory. Based on this, we have so many applications used in laboratory for blood and urine test, used in dairies and home to separate the butter and cream, used in washing machine to squeeze out water from the wet cloths. These are all some of the methods how can we separate the mixture. The remaining topics we will discuss in the part 2. Thank you so much for watching my videos. Like, share, subscribe my channel. Thank you so much.